Alright, so now we are going to finish up with our last section, section 12.5, which is dealing with problem solving with the normal distribution. Now, for this you are going to need your z-score and percentile table, which you can find on page 822. Now, what that table represents is the percent, or rather the percent of our data that lies to the left of any given z-score. Okay, so if we look there at the z-score of 0, so if we look at our z-score that corresponds with 0, okay, so we have a z-score equal to 0, we'll see that that corresponds to the 50th percentile. What that means is 50% of the data is less than it, which if we look at our normal distribution, we'll note that makes sense. That 50% of our data lies to the left of our mean. Similarly, you can see all those other values there. Now, if you're trying to find a percentile of something that lies between two of those z-scores, all you'll do is just take the average of them. Okay? So our table there is just telling us the area to the left. Now, normally this would be the time where I say, aha, here's where all of these numbers come from and how you can calculate them. But unfortunately, I can't do that because these are approximations of what we call non-integrable functions. That is to say, they are functions that have antiderivatives that do not have closed forms. Now, that'll be something that you understand more when you take calculus. But for our purposes, we'll just say we have the magic of the table on page 822, so we're just going to go ahead and use it. Okay? So now let's go ahead and just take a look at some examples here to get ourselves comfortable with finding these percentiles. Okay? So in 1 through 8, they just say find the percentage of the data in a normal distribution that lie below and above. Okay? So let's start by taking a look at number 2. So for number 2, it says find the percentage that lie below if we have our z-score of 0.8. Okay? So if you look in your table on page 822, you will see that 78.81% of the data lies beneath it. So that's just our answer to A, just what we find in that table. Now, if we want to figure out the percentage that is greater than that, what we are going to do is just take 100% minus that 78.81%. This will give us our 21.19% of our data that lies above. Okay? So the percentage below, that's just what you find in the table. The percentage above is just 100% minus. Let's do another one here real quick. Number 4 says we have a z of 1.4. So 1.4 standard deviations above our mean there. So we're just going to look into our table on page 822, and we'll see that that gives us 91.92% of our data lies beneath that. So it's a 91.92 percentile. Then to find out what's above, we're just going to take 100% minus it. And we should get 8.08% lies above. So that's how we're going to go about doing these things. So if we want to know above, so let's just go ahead and use our diagram here. So if we want to know what is below a given data point, if we have z equals b, well, the percentage less than that, that's just going to be what you find in your chart. So let's just use the table. Then, if you want to find what's greater than that, you'll take 100% minus the value in the table. So then our third case that we haven't yet seen an example of is, hey, what if we want to know the amount between two values here, say A and B, and we want to know the percentage of our curve that lies between these two. Okay. Well, to see that, I'm just going to draw a little diagram here. So for less than B, we would just find our value in the table. For less than A, we would also just find the value of our table. Well, if we look here, if we were to take this part here and subtract this part here, so then we would end up erasing this little part here. So if we did that, we'd note that we would no longer have this part here, and we have all the values less than this, so that means we're going to go to this region here. That is to say, that if we want to find the area between our z equals A and z equals B, we will subtract the percentile of A from the percentile of B. So let's go ahead and see what that looks like. So let's take a look at number 10. Number 10 says, find the percentage of data items in normal distribution that lie between z equals 0.3 and z equals 2.1. So what we're going to do is look up our table values for each of these. So let's start with our 0.3. If we look at our table, we'll see that that's 61.79%. For our 2.1, we'll see that we have 98.21%. So now to find the area that lies between them, what we are going to do is we're going to take our 98.21% and we are going to subtract 61.79%. When we do that, we end up finding that we have a value of 36.42%. So 36.42% lie between z equals 0.3 and z equals 2.1. So now, let's go ahead and take a look at some application-related exercises here. So if you want to take a look at anything I've had, pause the video now. So let's go ahead and take a look at, say, problems number 18, and then we'll take a look at number 24. So let's start with number 18. This is on page 826. It says, systolic blood pressure readings are normally distributed with a mean of 121 and a standard deviation of 15. So when we see a mean, we're just going to plop down. That's our x-bar. So our x-bar is 121, and our standard deviation, sigma, is 15. Okay? So we want to know what is the percentage of people with blood pressure readings below 148. Okay? So we want to know below 148. Well, to figure that out, what we need to do is first we need to find what is z of 148. So we're going to need to calculate that z-score. So we're going to do this just like we did in the last section. So we're going to take our data item, 148, minus our mean, 21, over our standard deviation, 15. 148 minus 121, that'll give you 27, over our 15, and then 27 divided by 15 is just 1.8. Okay? So now, what we need to do is turn to our table on page 822, and then we'll look for the z-score of 1.8. When we do so, we'll see that it has a percentile of 96.41. So that tells me that 96.41% of people have a blood pressure below 148. Okay? So for these, if they give you just the standard deviation and your mean, what you're going to do is you're going to find the z-score of that data point. So after you find the z-score of your data point, then you'll look up the percentile of that. Okay? Then, number 24, this wants to know, well, hey, how many have blood pressure between 145 and 157? So here we have two values that we're looking at. So we need to find what z of 145 is, and we need to find what z of 157 is. So let's go ahead and start with 145. So we're going to take our data point 145 minus our mean 121 over standard deviation 15. So we should get 24 over 15, which is 0.6. Then, when we're finding z of 157, we're going to take 157 minus 121 over 15. This is 36 over 15, which is 2.5. So now we're going to find the percentile of each of these and then find their difference. Okay? So a z-score of 1.6 has a percentile, which you can find in that table, of 94.52. Additionally, if we look at 157, that has a percentile of, or if we look at the z-score of 2.4, we'll see that it has a percentile of 99.18. So then, to find that what lies between them, we will simply subtract these percentiles. When you subtract them, you should get a grand total of 4.66%. So if you want to know between two values, find the percentile of one of them, find the percentile of the other, and subtract. Let me know if you have any questions on these. The next thing I want to mention is that when we are looking at which thing is going to be more impressive or which one is larger, we won't be looking at the raw totals. Instead, what we want to do is we want to find the percentile of each. Okay? So, if we were wondering which is going to be better, so we just need to find our z-score. So if we have an IQ, which is normally distributed, and let's say we have a data point, so let's start that we have a mean of 100, and then we have a data point 120, and a sigma of, let's say, 20. And then we'd see the z-score here is 120 minus 100 over 20, which is 1. Now, if a person took an IQ test, and let's say the x-bar for that one is 100, but then let's say that the sigma for that is instead 10. If a person got 115, which is a lower raw score, we would see that the z-score there is 115 minus 100 divided by 10. So that's 15 over 10, which is 1.5. So you'll note 1.5 and 1 are the z-scores, so the quote-unquote more intelligent person, or the one with the higher IQ, is actually the one with this lower score because they have a higher z-score associated with that score. Hopefully that makes sense. If you have any questions, please let me know. This is all the material I wanted to cover, so then I will give you your practice exam on Wednesday. Let me know if you have any questions.